Okay, so voltaic cell அப்படிங்கிறது என்னன்னு பாத்தீங்க அப்படின்னா electric cells or it's called batteries or it's called battery. Okay, so here battery பாத்தீங்க அப்படின்னா chemical reaction நீங்க பார்த்திருப்பீங்க. An electrolyte cells converts the chemical energy into electrical energy. So here we are going to have the zinc rod and copper rod. So carbon rod and zinc rod இருக்கும் உங்க புக்ல. பக்கத்துல பாத்தீங்க அப்படின்னா do you know பார்ட்ல ரெண்டு ராட் இருக்கும். ஒன்னு வந்து copper and zinc rod. And electrolyte solution பாத்தீங்க அப்படின்னா dilute sulfuric acid. So இங்க பாத்தீங்க எக்ஸ்பெரிமென்ட்ல என்ன நடக்குதுன்னு பாருங்க. So it's a copper rod and zinc rod. So here dilute sulfuric acid is a electrolyte solution. So zinc rod is reacted with the dilute sulfuric acid. It's in the glass. It's a glass. Dilute sulfuric acid is reacted with the zinc and it releases the 2 electrons and 2 protons. So the circuit is connecting through the copper wire, bulb, again wire, zinc rod and the electrolyte solution. So it is a closed circuit. When the charges are flow from this closed circuit, that current can flow. Here the dilute sulfuric acid is here. The dilute sulfuric acid is reacted with the zinc rod and it releases the electrons and protons. So electrons are flow from the zinc rod to that bulb, then bulb to the copper rod. Here zinc rod is produces the 2 protons and 2 electrons. We can take that example. It can release the 2 electrons and 2 protons. The 2 electrons are flow through this wire and 2 protons are emitted from the zinc rod and it is passing through the electrolyte and it is attracted by the copper rod. So it releases the 2 protons. So the zinc rod become a negative charge and that copper rod acquires the zinc Z++ ions. So that zinc plus ion is stick into the copper rod. That's why the copper become a positive charge. So the reaction releases the 2 electrons. The 2 electrons are flow from that wire and it is comes to the copper rod. And here the 2 protons Z++ ions are attracted by the copper rod and 2 protons are neutralized by the 2 charges. So that's called flow of current. So charges are flow from the zinc rod to copper rod. So the charges are flow from that one electrode to another electrode. That's called flow of current. So the flow of current are produced due to the chemical reaction between the zinc rod and dilute sulfuric acid. So that flow of electrons produces the electricity due to that bulb is glowing. So this is called electric cells or batteries. So the stick here, that copper rod attracts the Z++ ion. See that Z++ ion is attracted and it releases the 2 electrons. So it's a closed circuit produces the current. So it's called battery or electric cells. Okay. So commercially electric cells are called batteries. So நம்ம batteries அப்படின்னு யூஸ் பண்ணுவோம். நம்ம சின்ன பேட்டரியா இருந்தாலும் சரி, பெரிய பேட்டரியா இருந்தாலும் சரி, யூபிஎஸ்ல யூஸ் பண்ற பெரிய பேட்டரியா இருந்தாலும் சரி, எல்லாமே என்ன பண்ணோம் அப்படின்னா that chemical reactions are producing the current. So due to that reaction it releases the 2 electrons and 2 protons. Okay, the difference of potential between the 2 electrodes is 1.08 volt. That is a potential difference between the copper and zinc rod. So it's called electric cells and batteries. So next we are going to see the electromotive force. Electromotive force means it is not a force. It is a potential difference between the 2 ends of the battery. So you know that battery இருக்கு, பேட்டரியில ஒரு பக்கம் பாசிட்டிவ் எண்ட் ஒரு பக்கம் நெகட்டிவ் எண்ட் இருக்கும். The potential difference between the 2 charges, that is 2 ends, 2 terminals, that's called electromotive force. So electromotive force is not a force, it is a potential difference between the 2 ends. That is denoted in the unit of volt. So you know that when 2 positive charges are repel each other, then 2 negative charges also repel each other, but opposite charges are attract each other. So the electromotive force, the charges are the positive or negative charges are in the cells, then positive charge and negative charges are arranged in the 2 end. So the potential difference between the 2 end is called electromotive force. So 1.50 is the potential difference between these 2 ends. So it's called the electromotive force. So it is required for the flow of charges from one end to the another end. So it is used in the static electricity, electromagnetic induction, photoelectric effect, thermal effect, photoelectric effect, nuclear, piezoelectric effect. இதில் எல்லாத்தையும் நம்ம இதை யூஸ் பண்ணிருக்கோம். So ordinary battery working like this. So the charges are flow from the positive to negative, that is proton. Electrons are flow inside that battery. So like that, this is a 1.5 volt battery. So the two charges are arranged at two different two ends. So the potential difference can make the charge from one end to another end. So for chemical reaction completely over, that cells are increasing the internal resistance. So for freshly prepared cell, the internal resistance is very low. So புது டார்ச் லைட் பார்த்தீங்கன்னா பிரைட்டாக எரியும். ஏன் எரியும்னா அதில் ரெசிஸ்டன்ஸ் இருக்காது. எலக்ட்ரோலைட் சொல்யூஷன் வந்து ஃப்ரெஷ்ஷாக இருக்கும். ஸோ ரெசிஸ்டன்ஸ் கம்மியாக இருக்கிறதுனால பிரைட்டாக எரியும். அதே பார்த்தீங்க அப்படின்னா ஏஜ் ஆக the internal resistance is increases. Because the chemical reaction occurs, it converts the chemical energy into electrical energy. Then the internal resistance of the cell is increases. So when the internal resistance increases, so the flow of current will decrease. So that's why the torch lights are glow in a very dim when the aging of battery. Okay. So next thing is determination of internal resistance of a cell. So for battery la internal resistance irukku sonna. Internal resistance means the resistance is inside the cell. Electrolyte solution is there. So electrolyte solution also oppose the flow of charges inside the battery. So battery குள்ள current flow ஆகும்போதும் அது flow ஆகுற charge அந்த battery குள்ள இருக்கிற chemical அது வந்து என்ன பண்ணும் oppose பண்ணும். So that is called resistance. That resistance is inside the cell. That is called inside the resistance is called internal resistance of the cell. So now we are going to see the determination of internal resistance of the cell. Determination of internal resistance of the cell. Okay. So now we are going to see the internal resistance of a cell. See, this is the two ends of the battery. So this is positive terminal and this is negative terminal. We are connecting the external circuit like this outer surface. So current is flow from that positive terminal to negative terminal. And another one thing is, again the current is flow from the negative terminal to positive terminal inside the battery also. See, இதையும் சேர்ந்து current flow ஆனாதான் circuit close ஆகும். இல்லாட்டி circuit இங்க ஆரம்பிக்கும், வெளியில போய் இதோட முடிஞ்சிருக்கும். அப்படி complete ஆகல அப்படின்னா current flow ஆகாது. So current also flow from the negative terminal to the positive terminal inside the battery. So when the current is flowing through that inside that battery, that's called the internal resistance of the cell. Okay. So now you can see that current is flow from the battery from positive terminal to the negative terminal. So externally we can connect the resistance and the voltmeter to find the internal resistance of a cell. So in order to maintain the continuity, the current has to flow through the electrolyte of the cell from its negative terminal to positive terminal. So positive terminal negative terminal flow ஆனாச்சு அப்படின்னா தான் அந்த சர்க்யூட் க்ளோஸ் ஆனாதான் நமக்கு கரண்ட் கிடைக்கும். So internal current flow ஆகும்போது வரதான் internal resistance. Okay. So during the process, flow of current inside the cell, a resistance is offered to current flow by the electrolyte of the cell. So electrolyte அப்படிங்கிறது தான் அந்த சொல்யூஷன் தான் அந்த ரெசிஸ்டன்ஸ் கொடுக்குது. So internal resistance is inside the cell. So it's called internal resistance of the cell. A freshly prepared cell has low internal resistance and this increases with aging. So for aging, internal resistance increases due to the chemical reaction. So now we are going to see the determination of internal resistance of the cell. So here first the voltmeter is connected to the circuit, then battery. So it's a closed circuit, key is here. When the key is connected, current is flow from the battery to the voltmeter. So according to that Ohm's law, what will happen? Potential drop across the resistance. So V equal to IR. V equal to IR is the Ohm's law. According to the Ohm's law, the potential drop across the voltmeter here. So V equal to IR. That is a potential drop across that voltmeter. So it is a open circuit. It's not that key is not closed. So the current is flow only into the voltmeter. So now the resistance is external resistance is connected to the circuit. So when the key is connected, so what will happen? That current is flow through the resistance also. So here the resistance is, we can increase or decrease by using this now. So when the potential drop across the resistance R is V equal to IR according to the Ohm's law. Okay. According to Ohm's law, V equal to IR, that is the potential drop across the voltmeter. At the same time, here the resistance is connected into the circuit. that potential drop across the resistance also according to Ohm's law V equal to IR. So the potential drop across the resistance, this resistance V equal to IR. Okay, next one. So the current is flowing through the voltmeter. Voltmeter also has the resistance. So cell is connected, cell also has the internal resistance, that is small r. So V equal to E minus ER. Here see that E is the total potential of the battery. IR is the potential drop across the internal resistance. இங்க small r அப்படிங்கிறது வந்து internal resistance. So இந்த பேட்டரிக்குள்ள இருக்கிற internal resistanceனால வர potential drop அப்படின்னா எவ்வளவு அப்படின்னு பாத்தீங்கன்னா again according to the Ohm's law V equal to IR. அப்ப V equal to IR அப்படிங்கிற அளவுக்கு இந்த இடத்துல ஒரு potential drop ஆகுது. அப்ப நம்ம total potential வந்து E. இங்க potential வந்து E ன்னு வெச்சிருக்கோம்ப்பா. So E minus this internal resistance IR. So that is the potential of this circuit here. So you can write IR அப்படிங்கிறது இந்த பக்கம் கொண்டு வந்துறோம், V அங்க கொண்டு வந்துறோம். So IR equal to E minus V, that is equation number 2. Then dividing that equation 2 by 1. So what will happen? IR, I cancel each other. So remaining R value is there. R equal to E minus V by R into R. So you can get the equation of R equal to EV by V into R, where R is the internal resistance. If you know all these three values, E, V and R, you can calculate the internal resistance of the cell. So using this we can calculate the internal resistance of the cell. Okay. So next we are going to see the cells are connected in series and parallel. So last class நம்ம என்ன பார்த்தோம் அப்படின்னா resistance are connected in series, resistance are connected in parallel பார்த்தோம். So now we are going to see the cells are connected in series and cells are connected in